This is lecture 1-4, which is all about balancing redox equations. So you, as usual, should have completed your learning targets. There's really not a lot here for you to do ahead of time, so make sure that you have it set up in a skeleton. And then we are going to do a whole bunch of examples together. This is not difficult, but it's very tricky, and there are lots of many places that you could go wrong. So make sure that you have your skeleton set up, and then you're going to follow the examples as we go. Stop the video if you need to, and then restart it when you're ready. Okay, so let's go. So these steps are your rules for balancing by half reaction, and for the most part, they're the same as what you had in the book. The biggest difference is that this step right here, with the electron transfer, we are going to decide how many electrons are transferred based on the oxidation numbers of the things that are being oxidized or reduced, rather than finding them by balancing the charge on both sides. And this is to allow us to check the charge when we're finished, which means that really there's no reason that one of these equations should be incorrect once you have it balanced. They might be tricky, they might take a while, you might get lost in the middle, but there's no reason that any of them should be completely incorrect. So let's kind of walk through these steps as we're going, but we're going to start by separating into half reactions, and then we're going to decide the oxidation numbers of the things being changed, and then we're going to balance everything other than oxygen and hydrogen. We're going to add waters to the equation to balance the oxygens, and we're going to add hydrogen ions if necessary to balance hydrogens. And then if it's basic, we'll come back later after we've added half reactions together, etc. So I'm going to show you, I think it's easier just to kind of show you how these steps work. I repeated these steps for you basically on this slide as well here. And we're going to kind of go through them as we go. So we're writing net ionic equations, which means that I've gotten rid of the spectator ion. That would be like maybe a nitrate or a chloride or something like that. But we have aluminum reacting with copper 2 ions to form aluminum ions and solid copper. So the first thing that we need to do is separate this into half reactions. So we're looking for a reactant and a product that would match together as part of a redox. So we have the aluminum reacting to form aluminum ions, and we have copper 2 ions to form solid copper. So let's set this up in two separate half reactions. One with aluminum forming aluminum ions. Remember that aluminum ions has a charge of 3+. And one with copper ions, copper 2 ions, so they'd be 2+, forming solid copper. So this was separated into half reactions. Let's determine oxidation numbers. It's pretty easy in this case because there are no polyatomic ions. And so what we see here is we have solid aluminum, so it's 0. And the ion has the charge of 3+, so that's a +3 oxidation number. The copper has a 2+, so that's a +2 oxidation number, and solid copper would be 0. Now we're going to balance anyone other than oxygen and hydrogen. So in this case, there are no oxygens or hydrogens, and everybody in these equations are already balanced. We have one aluminum on each side, and we have one copper on each side. So we've taken care of the first two steps. Now we're going to add electrons to, one other thing that I didn't write in here that's really helpful is you want to decide for sure that you have an oxidation and a reduction. Remember that they have to go together. So when I look at this, the aluminum forming aluminum 3+, the oxidation number is going up. So this is my oxidation half reaction, and in the copper ions, going from 2+ to copper solid at 0 is a reduction in oxidation number. So this is the reduction half reaction. Make sure that you haven't made a mistake, because if you have 2 of one and none of the other, then you know you can go back right now and fix it. So now we're going to add electrons to one side of each half reaction to represent the electron transfer. So remember, in an oxidation, this means that electrons are lost, which means they are produced. So my oxidation number is going from 0 to 3+. That's a difference of 3 electrons, and they have to be lost. So I'm going to add the 3 electrons to the product side in my oxidation. And in the copper half reaction, I have 2+ to 0, so this is a difference of 2 electrons. It's a reduction, so the electrons have to go in, and that means they're reactants, and I'm going to add my 2 electrons to the copper side of that reaction. So I've taken care of adding electrons. Now it says for reactions in acid, we have no hydrogens or oxygens, so we don't need it to be acidic or basic, and we don't have any other atoms to balance. So this step is irrelevant in here. But let's look at step 5. If necessary, equalize the number of electrons by multiplying the half reactions to get appropriate coefficients. So we're going to come in and see that my aluminum half reaction has 3 electrons and my copper half reaction has 2, and I can't have any extra electrons either going in or coming out. So the least common multiple is 6, which means I'm going to multiply the aluminum one by 2 and the copper one by 3. So that's what I mean by multiplying, and I'll show you what happens. I'm going to actually rewrite it to make it a little bit neater before I add them together. I'm going to line up my arrow so that you can see what's left and all of that. So in the rewrite step, we're going to rewrite 2 times this whole equation. So this will be 2 aluminum yields 2 aluminum, aluminum 3 plus and 6 electrons. And then my copper half reaction, I have to multiply by 3. So that will be 3 Cu2 plus, and 3 times 2 is 6 electrons, yields 3 copper solid. So I'm going to add this the same way you add equation in math. Anything that shows up on both sides get canceled. So the only thing that's in common on both sides here is my 6 electrons. And when I add this up, I get 2 aluminum and 3 copper 2 plus. Yields 2, I missed a charge here. Yields 2 Al3 plus and 3 Cu. So something that I didn't talk about is you can check your half reactions, and these were pretty simple, so I didn't check them, but you can check your half reactions for substance and charge before you even multiply them to make the electrons equal. So what I mean by that is when you're looking at the aluminum half reaction, before we multiply it by 2, I see 1 aluminum on each side. And then if I want to look at total charge, the left side is a charge of 0. Is a charge of 0 because the aluminum is neutral. And the right side has a 3 plus and 3 negatives. And so the right side is also 0. So the charge is equal. I can do the same with the copper. I see 1 copper on each side. The left side is 2 plus and 2 minus, which is a total of 0. And the right side is copper 0, so it is a total of 0. It doesn't have to add up to 0. It might add up to something different. So when we check this overall equation down here, I can do the same thing. I can see that I have 2 aluminum on each side, and I have 3 copper on each side. The total charge on the left, the aluminum is 0, and the total of the copper would be plus 6. And on the right, the 2 aluminum ions would be plus 6, and the copper is 0. So notice that the charge is the same on both sides when I'm finished. This is what I mean by verifying that the charge and the substances are balanced after they're added together. Okay? So that was a really simple example because there were no oxygens, and now we're going to make it harder. So let's see what we've got here. We're going to do the same exact steps. So the first thing that I'm going to do is split this into half reactions. So you should be able to see that the iron 2 plus yields iron 3 plus, and that would be 1 half reaction. And then my other half reaction is going to be Cr2O7 2 minus yields Cr3 plus. Okay, so the iron one is very much like what we just did. If you want, you can stop the video and try it yourself. Otherwise, keep listening. So in this case, we're going from plus 2 to plus 3. So this means that this is an oxidation because the oxidation number is going up. And in the chromium, before I go any farther, I need to figure out oxidation numbers. So it's 3 plus on the chromium ion on the right, but on the chromium in the dichromate, you can figure that out for yourself, but that's 14, 12 positives divided by 2 is plus 6. All right, so this is going from plus 6 to plus 3 for each chromium. So this is the reduction half, which is good. I have 1 of each. Okay, the next thing that I want to do is balance anybody who's not oxygen or hydrogen. So in my iron half reaction, there's one iron on each side, and that's already balanced. But in my dichromate half reaction, there are 2 chromiums in dichromate and only 1 on the right-hand side. So I'm going to put a coefficient of 2, excuse me, in front of the chromium 3 ion to balance the chromium. I'm ignoring the oxygen and the hydrogen, other than the oxygen and hydrogen for right now. Okay? Then, so I've done the first 2 steps. I'm going to add electrons to both sides of the equations, or to each half reaction, 1 to 1 and 1 to the other. So in my oxidation, I'm going from 2 to 3. That's 1 electron difference, and it's an oxidation, so they're being lost, and it's going on the right. In my chromium, this is a little harder. I have each chromium going from +6 to +3. This is a difference of 3 electrons for each chromium, and there are 2 chromium, which makes that a difference of 6 electrons, and it's a reduction, so my 6 electrons have to be on the reactant side. So I've added my electrons. Now, this is an acidic solution, so now we have to do step 4. And we're going to, by the way, I'm going to check the iron because I think that equation is done. I have 1 iron on each side. I have a 2+ charge on the left, and 3+ and 1- is 2+ on the right. And so my ions are balanced, my charge is balanced, so that half reaction is done. All right, so I'm going to get this stuff out of my way for a minute, but that half reaction is done. So now the other half reaction, you can see that the chromiums are balanced, but the charge is not, and their oxygen is not. So what I need to look at is how I fix that. So in acidic solution, I start by balancing the water, or the oxygen, by adding water to whichever side needs more O's. So since I have 7 O's on the left and no O's on the right, I have to add water to the right side of the equation. This is for step 4. All right. I see that I have 7 O's on the left. To get 7 O's, I have to add 7 water. But now this creates a new problem because I've just added H's, and I need to add hydrogen ions now to the other side to balance the hydrogens that I just added. So I'm going to come back to the other side, and they have to be hydrogen ions because this is an acidic solution. That means H+ ions. Okay. Notice that my H+ ions that I put on the right need to add up to the 14 hydrogens. Sorry, the H+ on the left have to add up to the 14 hydrogens that are on the right. So I'm going to put a coefficient of 14 in front of the H+. Now I think I'm done, so I'm going to check charge and substance. So let's look at this together. I see 2 chromium and 2 chromium. I see 14 hydrogen and 14 hydrogen. I see 7 oxygen and 7 oxygen. Now I need to look at charge. So on the left, I have a dichromate at 2- and 6 electrons, so that's a total of 8 negatives, and 14 positives gives me a total of 6+. And on the right, I have 2 chromium 3s, gives me 6+, and water is neutral, so that would be 6+. So my substances and my charges balance, which means my half reactions are good. So I'm done with step 4. Okay. Now let's equalize the electrons. I need to do that because I have 6 in the chromium one and 1 in the iron one. So I need to multiply the iron equation by 6, but I don't have to touch the other one. That will give me 6 electrons in each equation. And I'm going to clean them up and add it together. So I'm going to rewrite this with my arrows lined up so that I can see what's happening. 6 Fe2+, because I had to multiply by 6, and 6 Fe3+, and 6 electrons. That's that equation. I'm not multiplying the other one, so I'm going to have Cr2O7 2- plus 6 electrons plus 14 hydrogen ions gives me 2 chromium 3+ and 7 water. And now I can add these together, and my 6 electrons will cancel, and nothing else is in common. So I'm going to rewrite it as 6 Fe3+ plus Cr2O7 2- plus 14H+ yields 6 Fe3+ plus 2 chromium 3+ plus 7 water. And this should be my overall equation. We need to check substance and charge so that we know that everything is all hunky-dory. Okay, so I have 6 irons on each side. I have 2 chromiums on each side. I have 7 oxygens and 14 hydrogens. My substances are good. On the left, I have 6 times 3 is 18 positives and 2 negatives and 14 positives. On the right, I have 18 positives and 6 positives, and that's it, right? Uh-oh, what did I do wrong? Oh, I know what I did wrong. I copied this incorrectly, and this is going to be where you make errors as well, so be really careful. This is 6Fe2 plus from right there, okay? So this is not 18, but rather 12 positives, okay? So I can look at this and see what else is wrong. Nothing. I have 12 positives and 2 negatives. That's 10 positives, and 14 more is 24 positives total, and 18 and 6 is 24 positives total. So this checks, and I'm finished, and my final equation is this. Okay? All right, I'm going to do one more long one with you, and then I'm going to show you some shortcuts. So I know that this is making this video a little longer, but you didn't have much to do ahead of time. So actually, I may save the shortcuts for class. I'll put them on here and see, but you can not have to watch the video. So we'll save the shortcuts for class after you're finished. So let's come back in, and now we're going to do this in basic solution. So the only thing that changes is we do this exactly the same way as we just did in acidic solution, but we pretend that it's acidic and then we transfer it to basic. Other textbooks will tell you this is the way your book does it, but other textbooks may tell you to do it differently. But if you do it this way, it lets you check with your substance and your charge. Okay, so I'm a big fan of making sure that you have answers that you can check. So the first thing I'm going to do is decide my half reactions. This will be CN1 minus forms CNO1 minus, and the other one is going to be MnO4 1 minus forms MnO2, the compound. I'm going to come up with oxidation numbers for everybody. This is kind of a challenge. So the nitrogen would be -3, and there has to be an extra negative, so the carbon will be +2, and the nitrogen will be -3. And then over here, the nitrogen is going to be -3, and the oxygen is going to be -2. That's 5 negatives. I have to have an extra negative, so the carbon will be +4. In permanganate, the manganese is +7, and in manganese dioxide, or MnO2, manganese 4 oxide, the manganese is +4. All right. I'm going to make sure that I have an oxidation and a reduction. So notice that the carbon is changing from +2 to +4. That's an oxidation. And the manganese is changing from +7 to +4. That's a reduction. Now I'm going to work with these one at a time so that you can see it. The carbon is balanced, and the nitrogen is balanced as well. I would need to fix that if it wasn't, but it would be hard to do otherwise. I'm going to come back in and go from how many electrons. So this would be +2 to +4 is a difference of 2 electrons, and it's an oxidation. So I'm going to put my 2 electrons in the products. I'm going to add, if this is basic, I have to treat it like it's acidic first. So I'm going to add water to the side that needs more oxygen, which would be the left. And I only need 1 because I have 1 oxygen. And now I'm going to add hydrogen ions to take care of the hydrogens that I just added. So that would be 2 of them. And I'm going to check everything. So a carbon, a nitrogen, an oxygen, 2 hydrogens. Total charge on the left is -1. Total charge on the right is -1, -2, and +2. So those cancel, -1 on each side. So basically my charges and my substance are balanced. Okay, now I'm going to do the same on the right side because I'm going to wait. Now, if they actually I'm not. If they ask me to do this and they want the half reaction, I have to change this half reaction to a basic reaction. Right now it's acidic because there are hydrogen ions. So this step right here says balance it in acid first, and then add hydroxide to both sides of the equation for every hydrogen ion that appears. You could do this at the end and it would be faster, but if they ask you for half reactions, you have to do it now. So I'm going to do it now just so that you can see how this works. So notice that in this equation, I have 2 hydrogen ions. This means to neutralize them, I have to add 2 hydroxide ions. And just like in math, I can do whatever I want as long as I do it to everybody. So I'm going to add 2 hydroxide ions. This makes kind of a mess, so I'm going to clean it up. And these 2 hydrogens and 2 hydroxides will be able to form in solution 2 waters. Now I have 2 waters on the right and 1 on the left, so I'm going to cross out what's in common, and that's going to leave me with 1 water on the right. And I can rewrite this half reaction as CN1 minus plus 2OH minus yields CNO1 minus plus 2 electrons plus 1 water. And I can check substance and charge again to make sure that I'm correct. I see 3 negatives on the left and 3 on the right and the same number of substances, so that half reaction is complete. All right, let's go back and do the same thing with the permanganate reaction. So I see MNs are already balanced. I go from +7 to +4, so that's a difference of 3 electrons. It's a reduction, so my 3 electrons go on the left. I'm going to then balance the oxygens. So now notice that there's 4 oxygen on the left and 2 on the right, which means I need more oxygen on the right. And as a matter of fact, I need 2 more, so I need to give it 2 waters. That gives me 4 hydrogen ions that I need to balance on the left. And I can check substance and charge. I see 4 oxygen, 4 oxygen. I see 4 hydrogen, 4 hydrogen. Total charge on the left is 3 plus and 1 minus. Sorry, 3 minus and 1 minus, which is 4 minus. A total of 4 plus. Neutralizes it out to 0. And on the right, the total is neutral because everyone's neutral. So that half reaction is balanced. I need to now make it basic. So I'm going to, come back in. I'll do it in blue again and add 4 hydroxide to each side. This makes 4 water on the left. I have 2 water on the right, so I'm going to cancel that out and make it 2 water on the left, and now I'm going to rewrite it. So MnO4 1 minus plus 3 electrons plus 2 waters that were left yields MnO2 plus 4 OH minus. Okay, now I'm to the step. I actually have to add a page here because I need more space. So now I'm to the step where I see that one equation has 3 electrons and one has 2. So I'm going to have to come back in and multiply the top one times 3 and the bottom one times 2, times 2, and clean it up. So I'm going to do that. That gives me 3 Cn minus plus 2 OH minus, plus 2 times 3, or 6 OH minus, and 3 CNO minuses, and 6 electrons, and 3 water. That's the first half reaction. The second one is 2 MnO4 minuses, and 2 times 3 is 6 electrons, and 2 times 2 is 4 water, and my arrow. Then 2 MnO2 and 8 hydroxides. So now when I go to add these together, it actually is kind of a mess. I have stuff everywhere that's in common. So notice that I have 6 hydroxides on the left and 8 on the right. I'm going to get rid of those and make that 2. I have 6 electrons. Those guys can go away. I have 3 water on the right and 4 on the left. So the 3 go away, leaving me with 1. And I'm ready to add those together. 3 Cn minus plus 2 MnO4 minus plus water, one of them, yields 3 CNO minus, 2 MnO2, and 2 OH minus. And I'm going to check everything one last time. So this would be 3 carbon and 3 nitrogen and 2 manganese, and 4 times 2 is 8, 9 oxygen, and 3 and 4 is 7, and 2 more is 9. 2 hydrogen and 2 hydrogen. On the left, The charge is 3 negatives and 2 negatives. So that's 5 negative total. And on the right, there's 3 negatives and 2 negatives. So that's 5 negative total. So my final equation for this reaction is right there. Okay, so I'm actually going to make a second short video that you can, that I'll link, that you can watch separately if you want to know the shortcut, or you can do that in class. So I'm going to stop this video here and start a new one in a minute that shows you how to make shortcuts. Thanks.